So let's begin with the next chapter, work, energy and power. Okay. So before learning about the work, we need to understand the scalar product of vectors, and we'll also see the vector product of vectors. Okay. So what is scalar product? So suppose you have two vectors, you take their product and the resultant is scalar. Then in that case, the product is known to be scalar product. Okay. So you will say, how come? You are taking two vectors, you are multiplying them and you are getting a scalar. So example of this thing is work. Okay, we are going to study work, energy and power. So work is a scalar quantity. It doesn't have any direction, but it is product of force and displacement. Right, it is product of force and displacement. So we can understand it like this. So suppose you have this force F bar acting on this block. So now this block, it moves in this direction, suppose. Okay, it moves in this direction. So the angle between force and displacement is suppose theta, right? So for an example, you take a rope and you connect it to this block and you pull it. So you pull it in this direction, but the block begins to move in this direction. There is no displacement along y direction. Okay. So in this case now, what would be the work done by this force? What would be work done by this force? So what we can do is we can resolve this force along two perpendicular components. So one component would be f sine theta, which is vertically upwards, and another component is f cos theta. Okay, it is directed in horizontal direction. So I can say that work is the displacement multiplied by the component of force in direction of the displacement. Okay, so which of these two components is doing work? There is displacement in x direction only. So only this component is doing work. F cos theta is doing work. F sin theta is not doing any work. Okay. So work done by F cos theta would be equal to that component F cos theta multiplied by the displacement in this direction. And work done by F sin theta would be this component, magnitude of this component F sin theta multiplied by displacement in this direction. Okay. So I can say the total work done is equal to x component multiplied by displacement in x component, displacement in x direction, y component multiplied by displacement in y direction. But this displacement in y direction is 0, so you get work done by this force is equal to what? F cos theta multiplied by displacement in x direction only. Okay. So now you have magnitude of force, which is F, magnitude of the displacement. Okay, this block moves from here to here, so magnitude of displacement you have, that is S, and there is some angle between them, and you get this formula for the work, which is F into S multiplied by cos of theta. So now see, you are taking two vectors, force and displacement, and their their product is, okay, work, which is a scalar. So from this we get definition of a scalar product. It is magnitude of one vector multiplied by magnitude of second vector multiplied by cos of the angle between two vectors. Okay. So this is the definition of the scalar product. W equals to F into S into cos of theta. Right. So for an example, you have two vectors A bar and B bar. Angle between them is theta. Then what is scalar product of these two vectors? So it is A multiplied by B multiplied by cos of theta. Okay, this is clear? Yes, no? Okay. Now, after that, so see, now we can define vectors in terms of their components along xyz axis. Okay, we can write the vectors in resolved form. So I can write A bar is equal to, suppose, ax multiplied by I cap plus ay times j cap plus az times k cap. B bar is bx into I cap plus by times j cap plus bz into k cap. And suppose C equals to A bar dot B bar, which is AB cos theta. Okay. So now if you write A as A like this, B like this, and take the dot product. Okay, scalar product is also called as dot product of two vectors because it is represented by a dot. So if you take the dot product, what do you get? Ultimately, you get this formula. Okay, A bar dot B bar is equal to AX BX plus AY BY plus AZ BZ, because you will have I cap dot I cap equal to J cap dot J cap equal to K cap dot K cap, which will be equal to 1, and I cap dot J cap equals to J cap dot K cap equals to K cap dot I cap equals to 0. Okay, so that means if you have unit vectors in same direction and if you take dot product of those unit vectors, the result will be 1. And if you have unit vectors in perpendicular directions and you take their dot product, then the result will be 0. And therefore, when you multiply this AX into I cap with this thing, BX into I cap plus BY into J cap plus BZ into K cap, what happens is only the component in same direction, the product with component in same direction will survive, others will vanish. And therefore, you have AX BX plus AY BY plus AZ BZ. So this is, if you have vectors in resolved form, their scalar product will be found like this: AX BX plus AY BY plus AZ BZ. Okay, this is simple. Then just based upon these things, let us see some problems. Okay, particle moves from a point. This is the initial point minus 2I plus 5j cap to 4j cap plus 3k cap when a force of 4I cap plus 3j cap newtons is applied. How much work has been done by the force? Tell me, what should we do? Right, right. So you are given with the initial position vector. It is suppose r1 bar. It is minus 2I cap plus 5j cap. You have final position vector r2 bar, which is how much? 4j cap plus tk cap, and you find displacement delta r bar, or you call it s bar, which will be r2 bar minus r1 bar, and that is equal to, so it is, there is no I here. Okay, so what will be its I component? It will be minus of minus 2I cap, that is 2I cap. Okay, plus you have 4j cap minus 5j cap, so it will be minus 1j cap, or minus j cap I can say, plus you don't have k here, so 3 minus 0, it is plus 3 k cap. So we found delta r bar. Then we can find out work. So work will be equal to, there is no bar. Okay, it's a scalar quantity. So it is f bar dot delta r bar. Okay, so that is 4I plus 3j dot product with 2I minus j plus 3k. Okay, and that is equal to 4 times 2 a, no I. Okay, it's a scalar, it has only magnitude. So 8 times 4 times 2 is 8, then 3 times minus 1 is minus 3. Okay, and there is no k component or z component in this one, so it is 0 times 3, 0 we can say. Okay, so 8 minus 3, 5 is the answer, right? It's option C. So this is very simple question, and surprisingly there have been questions like this thing also. Okay, this question also. So this is clear. Okay. Next question: a uniform force 3I cap plus j cap Newton acts on a particle of mass 2 kg Hence the particle is displaced from position, this initial position, to position 4 I cap plus 3 j cap minus k cap meters. The work done by the force on the particle is. So we'll do this in similar way, right? So okay, this is just like the last one. So tell me, what is displacement? 4 minus 2, right? So this is initial, this is final. So it is 2 I cap, 3 minus, there is no j cap here. So plus 3 j cap and minus 1 minus 1. So that's minus 2. Am I correct? And force is 3I plus j. So F bar is 3I plus j. So work done is equal to 3I plus j cap. It's dot product with 2I plus 3j minus 2k. Okay. And in exam you will not write this thing, this thing. What you will do is you will find this vector. Okay. Then just 3 times 2. Okay. Plus it is 3 times 1. So 3 times 2 is 6. 6 plus 3 times 1 is 3. So it is 6 plus 3, 9. Okay. Right. Because you won't have this much time. This is simple, right? There is nothing in this. Let's see next one. The body moves a distance of 10 meters along a straight line under the action of 5 Newton force. If the work done is 25 joule, then the angle between the force and the direction of motion of the body is. Tell me. Right. W is F into S into cos of theta. So angle we have to find out. Okay. So distance is given, work done is given and force is given. So it is F into S multiplied by cos of theta. Okay. So F is how much? It's 5. S is how much? It's 10 multiplied by cos theta and work done is 25. So this is 50. Let's move it on this side. 25 upon 50. Okay. Cos of theta equals to half. So right. So theta equals to cos inverse of half 60 degrees. Okay, good. Next question. A body constrained to move in y direction is subjected to a force given by F bar equals to minus 2 I cap plus 15 j cap plus 6k cap Newton. The work done by this force in moving the body through a distance of 10 j cap along y axis is. This is very simple. Okay, just multiply y component with this thing. Okay, so it is 15 times 10 because displacement is only along y direction. So 15 times 10 is 150. So this is the answer. Okay. Next question. When a body moves with a constant speed along circle, option A, no work is done on it. Option B, no acceleration is produced in it. Option C, its velocity remains constant. Option D, no force acts on it. Tell me. Why option B? Okay, speed is constant, but we have studied if you have circular motion, there is always some acceleration acting on the particle, okay, which we call centripetal acceleration, right? So speed is constant, but the direction of velocity keeps on changing at each and every point, and because of that, there is acceleration, which we call centripetal acceleration, okay, AC bar. So acceleration is not zero, right? Work done is zero, okay, work done will be zero. Option A is the answer. Why? Reason is you have force along the radius and towards center. We call it centripetal force. And at each and every point, what is displacement? So this is displacement. If you consider this point, it will move a little bit in this direction for very short time. If you consider very short time, it will move by very small distance in this direction. Okay. So at each and every point, we can say force and displacement are perpendiculars to each other, and therefore work done will be equal to what? Magnitude of force into magnitude of displacement multiplied by cos of the angle between them. And cos 90 we know it is 0. So work done is equal to 0. Okay. So there is no work done. All right. So now there might be a question. Okay. So some students think it like this, that in circular motion, particle starts from here, it comes back to the same position. There is no displacement. Therefore, there is no work done. Okay. But this concept will break down if you consider only displacement from here to here. Then will there be any work done? Still the particle has moved along a circular path from, let's say, this point to this point. This is not a full circle. Still work done will be equal to 0. So it's not because of the particle comes back to the same position. Okay, there is no displacement. Even if you consider a small section of circular motion, work done will be 0, because always the angle between force and displacement is 90 degrees. Okay. Yes, no? Okay, good. So then now what are the uses of dot product or scalar product of two vectors? So one of the use is to check whether two vectors are perpendicular or not. Okay. So just like we did in this example. So how will you check if two vectors are perpendicular? Take their dot product. Okay. So A bar and B bar are perpendicular to each other. Their dot product will be equal to 0. Okay. So if dot product of two vectors is 0, that means they are perpendicular to each other. Okay. This is very simple, right? And let's see some examples on this. So if vectors A bar is equal to cos of omega t I cap plus sin omega t j cap, and B bar equals to cos of omega t by 2 I cap plus sin of omega t by 2 j cap are functions of time, then the value of t at which they are orthogonal. Orthogonal means perpendicular to each other is. So what should we do? Let's take the dot product, right? So they become perpendicular to each other. We want to find out that time when they become perpendicular. Okay. So A bar dot B bar equals to what? Cos of omega t times I cap plus sin of omega t times j cap dot cos omega t by 2 times I cap plus sin omega t by 2 times j cap. Okay, so this, okay, x component multiplied by x component, what do we get? Cos omega t multiplied by cos of omega t by 2 plus you have sin omega t multiplied by sin of omega t by 2. So what is this? You have cos A cos B plus sin A sin B. This is cos of A minus B, right? This is cos of A minus B. So what is A? A is omega t. What is B? B is omega t by 2. So I can say this is cos of omega t minus omega t by 2. Yes, no? Okay. So this is equal to cos of omega t by 2, and now we know omega can be written as what? Okay, cos of omega t by 2 is equal to 0. Okay, that means omega t by 2 is equal to 90 degrees. That is pi by 2, right? 2 will get cancelled out. Take that omega on the other side. So we get t equals to pi by omega. This is the answer. Option A. Is this clear? Yes, no? Okay. Next question. If a vector 2i cap plus 3j cap plus 8k cap is perpendicular to vector 4j cap minus 4i cap plus alpha k cap, then the value of alpha is. So once again, what do we have to do? Just multiply them. Okay, 2i cap plus 3j cap plus 8k cap is perpendicular to 4j cap minus 4i cap plus alpha times k cap. So it is 2 times 4, 8. Okay, 8 minus 4 times 3, or 4 times 3 is 12. Okay, so negative sign is there, and alpha times 8. So plus, this is, oh, they have written it in different way. Yeah, okay, this is 4j cap minus 4i cap. Right, right. Okay, so let's change this. Minus 4i cap plus 4j cap. Okay, thanks. So this is minus 8 plus 12. Okay, and this is equal to 0, right? Because they are perpendicular. So 12 minus 8 is 4. So 8 alpha is equal to minus 4, and therefore alpha is equal to minus half. Option B, right? This is very simple. All right. Then let's see next one. Vector sum two forces is perpendicular to their vector difference. In that case, the forces, option A, are equal to each other. Option B, are equal to each other in magnitude. Option C, are not equal to each other in magnitude. Option D, cannot be predicted. So tell me, what should we do? What is given here? You have two vectors, their vector sum. Okay, vector sum of two forces is perpendicular to their vector difference. So let's take two forces, F1 bar and F2 bar. Okay, what's given? I'm sorry. What's given? All right. So what's given? F1 bar plus F2 bar. What? F1 bar minus F2 bar is equal to 0. Vector sum is perpendicular to vector difference. Okay. Then what will be? Okay, let's multiply this out. So you have f1 bar dot f1 bar. Then you have f1 minus f1 bar multiplied by minus f2 bar. So you can say minus of f1 bar dot f2 bar. Then you have f2 bar dot f1 bar. So plus f2 bar dot f1 bar and minus f2 bar dot f2 bar. This is equal to 0. So now when you multiply two vectors, okay, f1 dot f2, f1 bar dot f2 bar. So it is f1 into f2 multiplied by cos of the angle between two. And if you take f2 bar dot f1 bar also, it's same. It is f2 times f1 multiplied by cos of the angle between two. Okay. So a bar dot b bar is equal to b bar dot a bar. But now here you have negative sign and here you have positive sign. So this thing will get cancelled. Okay. Then f1 bar dot f1 bar. What is this? This is magnitude of f1 square. Okay, this is magnitude of f1 square, right? What will be this thing? See, f1x into f1x plus f1y into f1y plus f1z into f1z, right? So f1x square plus f1y square plus f1z square. And you take this on other side. So this will be f2x square plus f2y square plus f2z square. Okay, you are multiplying, you are taking dot product of vector with itself. Okay, so what is this thing? What is magnitude of f1 bar? Square root of f1 square plus, okay, f1x square plus f1y square plus f1z square. Okay, so this is magnitude of f1 square and this is magnitude of f2 square and they are equal. That means magnitude of f1 is equal to magnitude of f2, right? Yes, no? Okay, so it is option B, right? This is clear. Okay, so at this stage itself you should arrive at the answer. Okay, this is magnitude of f1 square, this is magnitude of f2 square, this thing gets cancelled and this thing goes on other side. That means magnitude of f1 equals to magnitude of f2. Okay, all right. So then another use of vector product, not vector product, another use of scalar product is to find angle between two vectors. Okay, another use is to find angle between two vectors. So now let's suppose you have two vectors a bar and b bar and you want to find out angle between them. So we use one definition of dot product, that is when you have two resolved vectors, okay, ax into I cap, ay into j cap plus az into k cap, and similarly for b bar. Okay, then the dot product can be written as ax bx plus ay by plus az bz. And then the definition of dot product is magnitude of first vector into magnitude of second vector multiplied by cos of the angle between two. Okay, cos of the angle between two. So then you can move this magnitude of a and b on other side. So you get cos of theta equals to ax bx plus ay by plus az bz divided by ab. Okay, and therefore theta will be equal to what? Cos inverse of this thing. Okay, so this is simple, right? So let us see an example of this. So you have one vector, okay, a bar, which is p I cap, and you have another vector, okay, which is 5 upon root 2 I cap plus 5 upon root 2 j cap. Okay, now without looking at this thing, can you tell me what should be the angle between these two? These are two vectors. I will tell you. See, you have one vector which is along x direction. Okay, you have one vector along x direction. This is first vector. You call it a bar. And you have second vector. You have second vector whose x component and y component is equal. Okay, x component and y component is equal. So in what direction should it be aligned? Would it be aligned? Okay, in what direction is it directed? 45 degrees, right? Because x component and y component is equal. Yes or no? What will be angle? This angle, sorry, this angle will be tan inverse of y component divided by x component. So that is y upon x component. If you take, it's equal to 1. So tan of theta is equal to 1. That means this angle is 45 degrees. Okay. So angle between these two is, without solving, okay, or you can say solving in your mind only, you can say it's 45 degrees. Okay. But now let's suppose you want to solve this for some other angle. Okay. How will you solve? So you have cos of theta equals to a bar dot b bar divided by ab. So you take a bar dot b bar, and that will be equal to what? Ax bx into ay by. So there is no ay here. That means you have to take only ax bx. So it is 3 times 5 upon root 2. Okay. And magnitude of a is 3 and magnitude of b is, we have to find it out. So magnitude of a is square root of ax square plus ay square, that is 3. Magnitude of second vector b is square root of 5 upon root 2 square plus 5 upon root 2 square. So that is, you can take 5 common. Okay, it's 1 by 2 plus 1 by 2, that's 1. Okay, so that is 5. So magnitude of second one is 5. So you put magnitude of a, you put magnitude of b. So this 3 3 5 5 gets cancelled out and you get 1 upon root 2. So cos of theta is 1 upon root 2. That means theta is equal to 45 degrees. So this is clear. Okay. So now let us see some problems based upon this. The position vector of a particle is r bar equals to a cos of omega t into I cap plus a sin omega t into j cap. The velocity of the particle is option A directed towards the origin, option B directed away from the origin, option C parallel to the position vector, option D perpendicular to the position vector. So what will you do in this case? Have you seen this kind of vector earlier? R cos omega t multiplied by I cap plus R sin omega t multiplied by j cap. Have you seen it? Yes, we have seen it. Okay, in circular motion, right? So in circular motion, this is suppose the position vector of particle performing circular motion. Okay, then you can resolve this position vector along x and y axis. This angle is theta. We know omega equals to theta by t if it starts from here. Therefore, theta equals to omega t. Then x component will be, this is r or r bar, you can say. It is r cos theta or r cos omega t. Y component is r sin theta, or you can say r sin omega t. Okay, so this is the radius vector, because x component is a cos omega t, you can say r is equal to a, okay, and y component is a sin omega t. So this is a radius vector of a particle performing circular motion. Yes, no? Okay. So now what is direction of velocity in circular motion? It is perpendicular to the position vector. Yeah, it's tangential. It's tangential. That means it is perpendicular to radius vector. So answer is option D. Okay. So this is very simple. Just merely just by looking at this vector, okay, you should be able to guess this is position vector of a particle performing circular motion. Okay, so this is along radius, and in circular motion radius is perpendicular to velocity. So answer is option D. Okay, if you don't if you can't guess it, then what will you do? Still you can solve this. Okay, so just find out velocity. Velocity will be equal to what? Dr bar by dt, right? So a you can take common, then it is d by dt of this thing, okay, cos of omega t, which will be minus omega multiplied by sine of omega t by chain rule. Okay, derivative of cos is minus sine. You have omega t, not only t here. So derivative of cos of omega t is minus sine omega t multiplied by omega. Okay, then and you have this I cap, okay, plus j cap multiplied by, you have omega times derivative of sine omega t is omega cos of omega t, right? And then you can take a omega outside, okay, so it is minus I cap into sine of omega t plus j cap into cos of omega t. So this is your velocity vector. Now you want to find out angle between them, so you will do r bar dot v bar, okay, and if you do r bar dot v bar, so then r bar, in r bar you can take a common, in this one you have taken this thing common, so it will be a square omega, a from r bar, okay, multiplied by, you have cos of omega t multiplied by minus sine omega t, so which is minus cos omega t sine omega t plus, okay, x component, y component sine omega t, and here you have cos omega t, so plus sine omega t multiplied by cos of omega t, and these are equal, but this is with negative sign, so they get cancelled out, and that's why what you get is 0. So since r bar dot v bar is equal to 0, they are perpendicular to each other. Clear? Yes, no? Okay. So if you are able to guess, it's very quick, not even 20 seconds I can say. Okay. But if you can't guess, it will take little longer time, but still it can be solved. Okay. Won't take more than 45 seconds or something. Right? Let's see next one. The angle between two vectors. A bar equals to 3i cap plus 4j cap plus 5k cap, and b bar equals to 3i cap plus 4j cap minus 5k cap will be. So tell me again, what will we do? We want to find out angle. So dot product of two vectors. Okay. So it is 3 times 3, 9 plus 4 times 4 is 16, and 5 times minus 5. is minus 25 and this is 0, right? Because 16 plus 9 is 25 minus 25, so this is equal to 0, and therefore, okay, A bar and B bar, they are perpendicular to each other. Okay, so it is option A, right? So this is simple. Is there any question in this? Then let us see another use of the dot product of two vectors, and it is finding component of a vector along another vector. Okay, finding component of a vector along another vector. So for simplicity, let's consider these two vectors A bar and B bar, and I will resolve this A bar along two directions. Okay, x and y, you can say. So for simplicity, I have taken B bar along x axis. Okay, so now what I will do is I will find the components of A bar. So x component is A cos theta because this angle is theta. Y component is A sin theta. Okay, so what is component of A bar along B bar? It is A cos theta, right? Yes, no? Okay. Component of A bar along B bar is A cos theta. So for simplicity, I have taken this along x axis, but even if you rotate them, still angle between them will remain same, and still the component of A bar along B bar will be A cos theta only. The component will remain same, the magnitude of component will remain same. Okay, so the component of A bar along B bar, a component of one vector along other vector, will be equal to what? That magnitude of that vector multiplied by cos of the angle between two. Magnitude of that vector multiplied by cos of the angle between two. Okay, so how will you find cos of theta? So we know, okay, we can find cos theta using what? A bar dot B bar divided by AB. So component of A along B is equal to A cos theta. So that is A multiplied by A bar dot B bar divided by AB. Okay, so here A and A gets cancelled out, right? This is magnitude of A, this is magnitude of A. So it is just A bar dot B bar divided by B. Okay, it is just A bar dot B bar divided by B. Is the formula clear? Okay, so we have to remember this formula. Okay, so again, for simplicity, let's suppose A bar is this one, and I want to find out component of A bar in x direction. So what will be component of A bar in x direction or along? Let's suppose in place of x direction, I say B bar, which is equal to tan I cap. So what is component of A bar along this vector? So this vector is directed along x-axis, right? So component of A bar along x-axis will be equal to what? The 20 divided by 10, right? 20 divided by 10, that is 2. But now, if you want to find out component of A bar along x-axis only, because this vector is along x-axis only, you can just say it is 2. Right? No need to solve. Okay. What is component of A along y? Just 3. So if there is a question, what is component of A bar along, let's say 50 j cap. So what is its component? 3, because this vector is along y direction, and you want component in direction of this vector, means you want component in Y direction only. Yes, no, right? So sometimes we can just quickly find out the component, okay? Or I can say smartly we can find out, no need to use the formula, okay? All right, so this is simple. And if you want to find out, so let's suppose component along C bar, component of A along C. So it will be A multiplied by cos of theta once again, okay? And that is equal to what? It is just, uh, so, okay, it will be just what? What's our formula? A bar dot B bar divided by B. I'm sorry. Okay, so formula is A bar dot B bar. So it is A bar dot B bar. So it is this thing 3 j cap multiplied by 50 j cap. Okay, so 3 times 50 divided by magnitude of B. So what is magnitude of B? Magnitude of B is 50 only. Okay, not B, C. Okay, component of A bar along C bar is A bar dot C bar. Okay, what did I do? Yeah, that's fine, no? Yeah, I'm sorry. That's fine. Okay, component of A bar along C, it is just A bar dot C bar. Okay, so it's A bar dot C bar. There is no X and Y component here. So it is just 3 times 50, 3 times 50 divided by you have magnitude of C. So magnitude of C is 50. Okay, so this 50 will get cancelled out and it is equal to 3. Okay, but just by looking at this thing, we can find out the component because this one is directed along y-axis. So we want component along y-axis and that is just equal to 3. Okay, this is clear? Yes, no? Okay. So let's see some problems. Right? Given A bar equals to this, B bar equals to this, the component of A bar along B bar is. Okay, so what is component of vector A bar along B bar? It is just A bar dot B bar divided by magnitude of B bar. Okay, so A bar dot B bar is 2 times 1, 2 plus 3 times 1 is 3 divided by magnitude of B is square root of bx square plus by square, that is 1 plus 1, 1 square plus 1 square. So that is equal to what? 3 plus 2 is 5, 5 divided by root 2. This is the answer, option C. Okay, yes, no, simple. Next question. If A bar equals to 2i cap plus 3j cap minus k cap and B bar equals to this minus I cap plus 3j cap plus 4k cap, then projection of A on B will be. So projection means component. Okay, projection means component. So projection of A on B is equal to A bar dot B bar divided by B. So it is 2 times, okay, A bar dot B bar is 2 times minus 1 plus 3 times you have 3 plus you have minus 1 times 4, that's minus 4, and in denominator it is magnitude of B, so which is 1, 1 square is 1 plus 3 square is 9 plus 4 square is 16. So it is 9 minus 4, that's 5, 5 minus 2 is 7. Okay. Sorry. 9 minus 4 is 5. 5 minus 2. Minus 2. Okay. That's 3. So in denominator you have 16 plus 10. 26. So it's option C. Okay. Clear? Oh, it's 3 by 26. Option B. Right. So this is clear. Okay. So this is how we'll find out the components.